I record whenever I can. And he usually messes up. Okay, so this is 10.2 machines practice. Our practice question says a bicycle has a front wheel radius of 42 centimeters and a pedal gear with a radius of 14.1 centimeters. When the pedal that is connected to the chain is pulled with a force of 200 newtons, the wheel rim moves 15 centimeters. The efficiency of this part of the bike is 93%. I want you to find the IMA, the AMA, the force out, and the amount of chain that's going to move when the bike rim moves. So the first thing that we'll do here is we'll write down our numbers, and then we'll break them out. Break them down. So we have 42 centimeters, 14.1 centimeters, 200 newtons, 15 centimeters, and 93%. Now, I don't want you to worry about whether it's in or out yet. I just want you to tell me generally what each one of these things are. So what's 42 centimeters? Distance. 14.1 centimeters.
Radius.
Distance. 200 newtons.
Force.
15 centimeters. Distance. And 93%? Efficiency. Okay. Now, we've got some sort of goal and some sort of tool. In this bicycle, what's the goal and what's the tool? What's the goal of a bicycle? To turn the wheel. So this would be the wheel. And then what are we using to turn that wheel?
The force.
The pedal or the gear. The pedal's connected to the gear. We'll call it the pedal. That's fine. Okay, so now these D's are going to be either the pedal or the wheel. So which one's the 42? Pedal or the wheel?
The wheel.
The wheel. And the 14.1?
It's the other wheel pedal.
The pedal. And the 200 newtons?
That's force.
Is it the pedal or is it the wheel?
It's the
the 200 newtons being put in the pedal.
It's the pedal. The 200 newtons is applied to the pedal. Remember, the pedal is connected to the chain.
No, wait. How do you know that the first wheel is the one that's connected to the?
That tells us.
It
It says has a front wheel of radius. Yeah. Okay. Now we have this leftover D. We need to figure out what that D is. What's it say? It says the wheel rim, like on the outside, moves 15 centimeters. So this one we'll just call D rim, and we're going to set it aside. It's not really important yet. It's kind of like a little bit of extra information. And that'll help us solve part D. Okay, so now we need to decide which one's in and which one's out, which I've already written this part up here. So we can see that the goal is to move the wheel. So that's going to be our out stuff. So anything that says wheel, that's out. The tool itself is the pedal. That's going to be the in stuff. What?
The rim counts as the wheel, right?
The rim, it's not, I mean, it's on the wheel. You'll see. I'll get to it. It's not hard, it's just confusing is all. Okay, so part A, we're looking for the IMA. So we'll go over here. We have IMA here and IMA here. So we want to use equation 1, 2, or 3? 2. So this would be IMA equal to D in over D out. IMA equal to 14.1 over 42. Now centimeters are going to cross out. That's why we don't have any units. So you don't have to put them into meters because they're just a ratio. Notice that 14.1 is smaller and it's on top, so it kind of doesn't look like what we're supposed to have, right? But that's okay, because the goal of a bicycle is to go more distance than force. We're trying to translate force into distance instead of, like with the bottle cap, we were trying to translate distance into force. We wanted to increase our force. But here with the bicycle, we want to increase distance. So smaller on top, which means we're going to get less than 1. And that's okay. You just want to double check those things, make sure they make sense. So our IMA is equal to 0.34. Part B. What is our AMA? Which equation do we want to use? 1, 2, or 3?
Or no, 3.
Or your variables, right? We don't have force in and out. We only have force in, so we've got to use this. Percent efficiency equals to AMA over IMA. Now, this percent efficiency, I'm just going to turn this 93% into 0.93. And I'm looking for AMA, and I know my IMA is 0.34 because I just found it. That's just like a little translation you have to use. You can write this down to 100 and then do 93 divided by 100 to get to 0.93. That's okay too. It's just an extra step. So we're going to go 0.93 times 0.34. Times 0.34.
That equals 0.32.
Yes.
That's an increase for some reason.
Okay, part C. We're looking for the force out.
Okay.
So, which equation do I want to use?
That
First one.
The first one. Okay, now D is a little tricky. Yes, go ahead.
You just convert the percent efficiency.
Yes, I converted the 93% and just put it into decimal
You always
form.
have to.
It depends on which equation you use. If you use this equation right here, convert it to decimal form. If you use this equation right here, you can leave it in percentage because then you'll divide it by 100 anyways, which will put it back into the decimal form. Okay, here's the tough part. It says, how far is the chain pulled to move the ring? In other words, how much do you have to move the pedal for the wheel to move 15 centimeters? This one's not really a physics, I mean, it's physics, but there's no like equation for it. It's a ratio, right? It's just a proportion. So look at the picture. I think that might help a little bit. We have the wheel, here's the bike wheel, and it's going to move 15 centimeters. So this much is 15 centimeters. And here's the gear down here. We want to know how much is this going to move if that moves at 15. Is any of this starting to look a little familiar, like you've done it in math before?
Yeah. Yes.
Okay, so those numbers up there, there's two numbers up there that we're actually going to use. Which two numbers do you think we're going to use?
15 and 93.
15 and 93. Well, we've already got 15, so two more numbers from there. We have the wheel and the gear.
93.
293.
93 and 42.
Nope.
14 and 0.1 and 93.
Nope.
14.1 and 15. Wait, no. 14.
Trick question, none of
14.1 and 200.
Okay.
Yes.
I'm sure someone said it by now. I just can't hear with all the numbers being shouted at me. This is the wheel outer. This is the gear outer. On this picture, what else do we have? We have the radius of the wheel, and we have the radius of the gear. Right? Good? So, set up a proportion. We have the gear over here, We have the wheel over here. We have the radius, and we have the rim parts, the edges, if you will.
Rim shot.
So the radius of the gear is 14.1, and the radius of the wheel is 42. The gear, we want to know how much the gear is going to move when the wheel moves 15. It's just a proportion. This should help you when you get to your SAT and ACT problems. All right, to solve, you're going to have 14.1 times 15 over 42 equals x. And I got 5-ish centimeters.
Do some crazy math.
Proportions? No. It's not. Okay, how do you guys feel about that problem? I know it's kind of nasty.
That was
But
pretty.
it should cover everything.
That was hardcore.
Hardcore.
It's just a Friday.
Okay, it's okay until D. I know. Yeah, D's a little terrible.
It's fine until the D.
8 minutes.
I know, but some things get